Okay, so if we want to find the domain of all of these, you're basically looking for square roots. So you've got square roots there and fractions. Because anything else up to this point is going to just give you a real number. There's logarithms and different types of equations that have problems that the domain is different than all real numbers. But for this section, you're just gonna have to worry about these square roots. So if I plug in anything to x squared plus 5, I get an answer. So this domain is all real numbers. I can plug in anything I want and take the cube root of it, doesn't matter if it's negative, and then subtract 2. So this is also all real numbers. I have, oops, I didn't do this one. Okay, so I have a square root here, and I also have a square root here. Let's talk about this one first. This one's a little bit easier. You cannot take the square root of a negative number, so therefore the domain of that one is all of the positives. So you can say x is greater than or equal to 0, because I cannot plug in a negative number, or you can say it in interval notation and say 0 to infinity. Either way is fine. Now, this, the inside can't be negative. So if I do 8 minus 7, I'm okay. If I do 8 minus 7.5, I'm okay. But if I do even 8 minus 8.1, then that's going to be a negative number. And I can't take the square root of a negative. So the number that I subtract has got to be less than or equal to 8. If you picture a number line, anything bigger than 8 is going to give me a negative. 8 minus 9, 8 minus 10, 8 minus 20. So I can't use any of these. 8 minus 7.9, 8 minus 0, 8 minus a negative 2. Those all work. So you also could represent it as negative infinity to 8 with a bracket. It doesn't matter to me how you represent this. Now, a shortcut to that is to take whatever's on the inside, which would be 8 minus x, set it greater than or equal to 0, and then just solve the equation. So negative x is greater than or equal to negative 8, divide by negative 1, flip your sign, and you get the answer. So take the inside, set it greater than or equal to 0, and solve. If I have a fraction, I just cannot have 0 in the denominator. So x just can't be negative 7. So technically you could say negative infinity to negative 7 with the parentheses, and then negative 7 to infinity. So that's another way of saying the same thing. So here I have two things in the bottom, in the denominator, that I have to worry about. X cannot be equal to 0, and x cannot be equal to 2. Either of those numbers would give me an error. It would not be in the domain. Every other number is in the domain. This one's a little trickier because it's squared. So you have x squared minus 6 has got to be greater than or equal to 0. So x squared has got to be greater than or equal to 6. So don't just square root both sides and say that x is greater than or equal to plus or minus radical 6. It doesn't work that way. You've got to think about a number line. So you've got radical 6 there, negative radical 6 there. Anything between them, like if I plug in 0, 0 squared minus 6 is going to give me a negative. Anything that when I square it is smaller than 6 is going to give me a negative number. So those are negative, those don't work. That means these are going to work. Those are positive. If I plug in a decimal bigger than radical 6 and then subtract 6, I'm going to get a positive number. So the domain of this one would be negative infinity to negative radical 6 union radical 6 to infinity.